we have learned how to create a 1D beam element, orientation of 1D beam element, 3D view of an element, and the concept of CDEF points. In session 7, we will learn how changing orientation changes the CDEF points, the concept of current entity in HyperMesh. So first, let me show you the problem statement. So this is the case 1. Here we have a simple beam element of length 500 mm. The cross section is rectangle and it is subjected to a bending force. So here are the analytical solutions and the material as well. Now case 2 is also similar, but the only difference is the cross section is rotated by 90 degree. So I will show you the case 2 here as well. So in case 2, everything is same. The only difference is the cross section is rotated by 90 degree. So we do not have to solve the two problem statements separately. Once we solve the first problem statement, we can modify it and it will change to case 2. So we don't have to start from scratch. So now let me show you how to do that. In HyperMesh, we will select OptiStruct as a user profile and click OK. Next, we will follow the same process. Material, give the name to the material, give a color, type as isotropic, card image as mat1. Now click on create edit. Here we will define the Young's modulus as 1.1 10 raised to power 5 and new of 0.28. Now click on return and return. So the material is done. Next is HyperBeam. So go to 1D page, HyperBeam panel. Here we will select the section type as solid rectangle and click on create. Here we will have to define the two dimensions. So the first dimension is 100 and second dimension is 50. This is for case 1. So now you have to calculate the CDEF points. So C1, C2, D1, D2, E1, E2 and F1, F2, and we will input those values in the property box next. So go back to HyperMesh by clicking on this icon and click on return. Next, we will go to the property icon, give a name to the property, type as 1D, card image as pbeam, material as material and beam section as beam section. Now click on create edit. So here again I will enable continuation line 2 and define the values of C1, C2, etc, etc. So first C1 is 50, C2 is 0, D1 is 0, D2 is 25, then E1 is minus 50, E2 is 0, F1 is 0 and F2 is minus 25. Now click on return and return. So material is done, HyperBeam is done, property is done. Next is component. So go to component icon, give a name to the component, select the property and click on create and return. Now we will create the nodes. So geometry page, nodes panel. First we will create a node at 500, 0. Second I will create a node at 0, that is at the origin. So we will fit this to screen by pressing F from the keyboard and return. So to create the beam element, go to 1D page, bars panel. Now in bars panel, we will first select the property, then we will select the element type, and now we have to define the orientation. So right now I will keep the orientation as y-axis and then I will select node A and node B. So I will select the left node as node A and right node as node B, and the element is created. So if you want to see this in 3D view, you can go to this icon and enable detailed element representation. And if you rotate, this is how it will look like. So this is case 1. The force will act like this on the right side. So now go to return. If you want, you can also go back to 1D view by going to the same icon and enabling 1D representation. Now we have to remove the temporary nodes. So geometry page, temporary nodes panel, and click on clear all and return. Next we will create the load collectors. So go to load collector. Now from the previous sessions, you know that if you want to define both constraints and loads, you have to create multiple load collectors. So here we will have to create SPC load collector as well as force load collector. It simply means that we have to come back to this panel 2 times at least. So why do we have to come back to this panel 2 times? Why cannot I create both the load collector at once? So you can also create both load collectors at once. So first let me give the name as force, give a color, no card image, and click on create. As soon as I click on create, you can see on the model browser a load collector has been created. So if you expand this, you can see force load collector has been created. Now from the same panel, this time I will create a load collector SPC with a different color and create. Now both the load collectors are created at once. Now I can define both constraints and forces without coming back to this panel. So this will save me some time. But before going further, there is an important concept called as make current. So first let me explain that concept by going out of this panel first. So the current entity concept is nothing but if you create multiple load collectors, out of these multiple collectors, only one collector will be active at a time. So that active collector is what we call as current collector. So let me explain this with an example. Here in the image you can see 2 load collectors, SPC and force. One of the load collectors is highlighted in bold letters. So this bold letter collector is nothing but the current load collector. So now whatever you define goes into that load collector. So in the image, SPC is the current load collector. So if I define force, it will again go to SPC, not in force, because SPC is current. So if you want to make other load collectors current, you have to right click on it and choose the option of make current. So here you can see a problem is specified, and in the first figure, that is SPC and force, there are 2 load collectors. Force load collector is the current entity. You can judge by looking at the bold letters. Now everything that we define after this will go into force load collector. Doesn't matter if you define constraints or loads. Now in the second figure, you have SPC as the current load collector. That simply means whatever you define, even if you define force, it will go into SPC load collector. You can also tell by looking at the colors. So take a look at the color of the SPC load collector, which is blue, and take a look at the arrow in the second figure. It is also blue. That simply means that that arrow is under SPC load collector, which is wrong. So that is the concept of current entity in HyperMesh. So let me go back to the problem statement. Now here, if you take a look at our load collectors, since we created SPC recently, it is by default the current load collector. So let me just define constraints first. So go to analysis page, constraints panel, select the node where you want to apply the constraint. We will constrain all 6 degrees of freedoms. Load type is set to SPC and click on create. So the constraint is created. Now take a look at the color of this constraint and the color of SPC load collector. This is same. Now click on return. Now if I define force, Force will also go into SPC. That is something I do not want. I want force to go into force load collector. So I will right click on force and I will select make current. What this will do is this will make force as the current load collector. Now I can define forces by going to forces panel. So I want to define a force on this node. The value of force is negative 100,000 in y-axis. So click on create. So again you can take a look at the color of the arrow. It is red, just like the force load collector. Now click on return. Now we will create a load step. So analysis page, load steps panel. Make sure the type of analysis is set to linear static. Give a name. So the name of the analysis we are going to give is, let's say, case 1. For SPC, select SPC load collector. In front of load, select force load collector. Click on create and return. Now first save the file. So save as model. Give a name. So this case I am going to give the name as case 1. Now to solve, analysis page, OptiStruct panel, OptiStruct. This will start solving. Now go to results. Let me change it to XY plane. Go to contour and by default the result is displacement. Click on apply. So here it is showing me the displacement of 9.324. Now if you want to check the stresses, you can change the result type to element stresses, and here we will have to change the stress to nodes and points. So in this particular case, since the constraint is at node A, the stresses will be at node A. C point is the positive stress point, so I will select SAC and apply. So here you can see a value of positive 600. Similarly, at E point we should be getting negative stresses. So here it is negative 600, and at D and F you should have 0 stresses. So this is as per the previous problem we have solved. Now what if I want to solve case 2 without starting from scratch? So to solve case 2, all we have to do is change the orientation. So let me show you the problem statement again. So as you can see in the problem statement, everything is same, only the cross section is rotated by 90 degrees. So I will do the same thing in now HyperMesh. So back to HyperMesh, we will go to return. Now here we will simply change the orientation of this 1D element. So first let me show you the 3D view of this element. So if I rotate this, you can see this is the case 1. Now what we are going to do is we are going to change the orientation. So to do that, go to 1D page, bars panel. Now instead of creating the element, we are going to update the element. So select the option update. Once you select update, now it will ask you which element do you want to update. So select the element, change the property, or make sure the property and element are correct. Now we want to change the orientation to Z-axis. Now all you have to do is click on update and select what parameters do you want to update. So here we want to update all the parameters and click on update. So as soon as I click on update, take a look at the orientation. It has changed. So instead of creating the problem from scratch, all we did was rotate the orientation. Now all I have to do is save the file as case 2. Now let us solve this problem. So again go back to analysis page, OptiStruct, OptiStruct. So once it is solved, we will go to results. Again I will align it in XY plane. go to contour icon, result type as displacement, click on apply. So this time the result is changed to 3.66 10 raised to power 1, that is 36.6. Now if you want to see the stresses, change the result type to element stresses. Now this time the CDEF points will also change since the orientation is changed. So here, instead of having positive stress on C or negative stress on E, now we will have positive and negative on D and F, and C and E should have 0 stresses. So let's see, at SAC point we have a stress of 0. At SAD we have negative 1200, which means it is compressive. SAE, again we will have 0. SAF, we should have positive as 1200. So this is it for this session. Now let me show you the homework. So for homework, you have to solve the same problem statement with different cross sections. Each cross section you will have to assume case 1 and case 2. So all you have to do is rotate the cross section by 90 degrees. Now in some of the cases it is possible that after rotating the problem will remain the same, so you don't have to solve those, but for those cross sections that are going to change after changing the orientation, you will have to solve them and input the values in the table. So these are the first 5 problem statements. These are the next 5 problem statements for a total of 10 problem statements. And here you have the table where you have to input the values, analytical as well as those obtained from the software. So this is it for this session. Thanks a lot for attending session number 7. In session number 8, we are going to cover 1D beam element